This is section 4.2, number 13. It says, suppose a car loses 30% of its value every 3 years. A certain car costs $25,000. We want to write a function for its value after t years. So we're going to write this function of the form v of t is equal to v naught times b to the t, where v naught is the initial value and b is the decay factor. Okay, well, we know the initial value is 25,000. Okay, and the decay factor is going to be comprised of r, the decay rate, which is 30%. So we're going to take 1 minus r, or 1 minus 0.3, to give us this 3-year decay factor. But we really want an annual decay factor. Okay, so we're just going to raise to not 3, but the reciprocal. So raise to the 1/3 power, and that'll altogether be b, the annual decay factor. But then don't forget that b is raised to the t. Okay, so more simply, we get 25,000 times 1 minus 0.3, so 0.7, and then multiply the 1/3 by the t, so you get t over 3. We then want to graph this function on our calculator. So I've entered the function in y1, and I'm just going to try to adjust the window first using zoom 6, zoom standard, and then zoom 0, which is zoom fit. Okay, and that looks pretty good. The only difference, it does say to graph from t equals 0 to t equals 12, so I'm going to make my x max 12. And then I'll just go ahead and set my y min to 0. Okay, so the part that I'm concerned about is just this part of the graph that's to the right of the y-axis. Another way that you could adjust your window is to look at the table of values. You can see, the highest point in this region would be when y, or the value v, is 25,000, and then scroll to see what happens to the value over time. And then part C, it says, how long will it be before the car depreciates to $8,575? It does say use algebra. It's not necessary, but let's see if that is possible. Okay, so we're going to replace V with 8,575. Okay, and then the goal is to isolate the power, the 0.7 to the t over 3. That's our first goal. And so I would divide both sides by 25,000. So we get 0.343 is equal to 0.7 to the t over 3. And if you could write both of these sides of the equation using the same base, that would help us find the answer pretty quickly. Okay, well, 0.7 cubed is 0.343, and so then we get is equal to 0.7 to the t over 3. And now, if these bases are equal in the equation, the exponents must be equal as well. So that tells me that 3 equals t over 3, and then multiply both sides by 3. So we get t is equal to 9. Another option is to look at your table. You can just kind of scroll down until you find that value that was given, which was 8,575. Okay, another option, because we've entered this in y1, is to enter in y2 the value over time and then graph and find that intersection. So either way, whichever method you would like to use, we end up with 9 years.